So, the electricity has been easy so far, hasn't it, Go? Yeah. And today is also not so difficult. Nice, easy lesson. Yeah. Yeah.
It's kind of shadow inside hard, like be controlled by physics.
Yeah.
It's the kind of picture for electricity.
Alright, let's see. Physics, electricity, Ohm's law. I guess Carmen was okay because she didn't come back up. So the room downstairs must be free. Who's your math teacher? John, of course, yes, John.
That's for business?
Carmen teaches science. John doesn't like my maths book.
Why?
Because I put some very hard questions in it.
I mean the chapter 2.
In my maths book.
Oh, in your book.
The maths book you use is my maths book. She doesn't like it because I put some very hard questions in it. I'm very mean. Especially part 2, yeah.
We prefer the hard question. We prefer a question for us just put in here and make us solve that for like maybe 30 minutes. We like this kind of question. We love this kind of question.
Yeah, me too. Me too. Alright, Ohm's law and IV graphs. Whoop. I didn't cycle today, Ben. I took the bus. Yeah, good luck. Right, you got that? Yep. So, not too much to do. Now, this circuit here is a very simple circuit. It's very important for 2 reasons. Number 1, your experiments you do, one of the experiments you do will be with this circuit. Okay? And I want to look at what happens in this circuit. So, just to be clear, we have a voltmeter. Oh no, actually, you should tell me. This is called voltmeter. What's this one?
Ammeter.
Resistor.
Battery.
Variable resistor. Now, if you look here, let me just draw this so I can make. So we have. Come on. We have OR. We have our power. We have a variable. And then here we put V, and here, or here, doesn't matter, we put A, and then we have our current, and it goes around like that. Now, let's just say the voltage here, we'll just say it's E, okay? This E here must be the same, remember we said that the voltage adds if it's in series. So this E here must be the same as the voltage here and whatever the voltage is here. Okay. Now you have the formula VIR. So what happens if you increase the OR? What happens to the V? V equals IR. So if you increase the OR, then what will happen to the V? It'll be bigger.
Yeah.
Now, if this, let me just call this Vx. If E equals V plus Vx, and the E here doesn't change, you know, because it's like maybe 1-2 volts, doesn't change. If the Vx gets bigger, what happens to the V? So if this Vx gets bigger, what happens to this V? Smaller. Okay, so the point is, by changing this, you can change this. And then what happens when this changes, this also changes. So you can move this with your hand, and then you can measure a V and measure an A, and they both change together. And what we'd like to do in a moment is to make a graph where we put V here and I here, this V and this I. Okay. Now, this is an important circuit. I see it in the experiments. I see it in the exam. Okay. I want you to copy this carefully in your notebook. There's only one thing that's missing. Can anyone see what's missing from my circuit? I didn't include it. For safety.
Switch.
A switch. I never put in the switch. So if you want, you could put a switch here. Okay. So you see up here you have V, I, or. Yeah? We're trying to study the relationship here. We can get different values of V and I by changing this. Yeah? So when you're ready, we can continue. Is that okay? Ben? Yeah, continue, guys?
Yeah.
Okay. Right, so here's an example. Here we have voltage and here we have current. And as the voltage gets smaller, we see that the current gets smaller. Now we'd like to plot this. So we usually put the V here. Why do we put the V here? Because that's the one we change. And then we measure the I. So the I goes here. Yeah? So, very roughly, try to just graph this. Okay? You don't have to be very accurate. I think it's clear what's happening. Do you see what's happening here? As the voltage drops, the current drops. Okay? And it looks like it's dropping the same each time. Okay? So just a rough sketch. Say again, sorry?
The voltage is
X. Yeah. Yeah.
V max and I is max and there.
No, you start at 1 on the
Yeah,
left.
you start in 1 to 20 and
1, 2, 2, 4, 3, 6.
yeah.
Yeah, you drew it? You drew? Show me. Yeah, it's okay. You didn't draw?
I saw it was this. Or maybe it's this.
Or maybe it's more
Sharp?
yeah.
Steep.
Yeah. Yeah.
Steep.
Steep, yeah, it's more like this. This one is right. Yes.
Oh, I'll draw it now, but do you know what to try to draw it, Cal?
I will change that later, it won't be right.
Ah, come on, believe. It looks like what those two guys drew. You're not saying they're smarter than you, are you? No, of course not. So you can draw it. Yeah. All right, where's my program? It's not opening yet. Oh, here we go. What?
No.
Right, so firstly we have, just give it a second. There we go. First we have voltage, and we measure that in volts. Then we have current, we measure that in amps. And I think the first voltage we had was a 10. So it goes 10, 9, 8, 7, 6, isn't it?
Yeah.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, yeah. And the current went
2, 4.
22, yeah.
2, 4, 6.
Yeah, like this, isn't it?
Yeah.
Okay, so let me draw this now. Insert. Come on. Insert chart. There you go. Scatter. This is called an IV plot. On the x-axis is voltage in volts and then current in amps. It's not showing me the... Here we go. That's better. Let me just shrink it down a little bit. Come on! What a... Oh, sorry. I don't know what I'm doing. There we go. That's better. Now, there we go. And you know what? I'll just leave it like that. So you see, you get a nice straight line. As the voltage increases, the current increases. So what does that mean? It means if you have a resistor and you measure the current that comes out and you measure the voltage that goes through it and you plot voltage and current, you get a straight line. Just like this. Okay? So I think you two have this drawn. So Gao, if you can just add this to your notes, and Khalifa as well. So this is called the IV plot.
Maybe it's too ugly.
Yours is too ugly?
Yeah.
Sorry, let me move this back up. Is okay, Ben? What's wrong?
It's okay.
Are you sure?
Yeah.
Are you sure?
Okay. Why you can see is the V is 2, 4, 6, and I is 5, 10.
Oh, that's just the program.
So it's like this or this.
It doesn't matter because it's your choice on your units here. So if I use 5, 10, 15, 20, or if you use 2, 4, 6, 8, you get a different picture.
That's why I was confused.
Yeah, but that's fine. That's fine. Continue? Okay. So, another name for this graph is called the IV characteristics of a resistor. And it's just a plot of the current against the voltage when the power source provides a varying voltage. So what that means is here, if you connect this to something and you change the power here, you'll get different current and different voltage and different current. This plot here of current and voltage, that's called the IV characteristics. Now, for this resistor, for this one, it was straight. But it's not always true. Just for this one it was. So each resistor has a different graph. And it's called the IV characteristics, this graph. You understand? It's different for each resistor. So I need you to write this down. okay with that? Got that?
Yeah.
Yeah? Yeah? No? Okay. Yeah? Does anybody know Ohm's law? Do you know Ohm's law? You know Ohm, resistance. Does anybody know Ohm's law?
Sorry. Okay.
Okay, so just before we continue, if I go back to this for a moment, if you have VI or, how do you calculate the or? That's V over I. Now this graph is I over V, so it means the slope is 1 over or, is the slope. Okay? Now because the slope, the gradient, doesn't change, it means the or doesn't change. So watch, if I just shrink this a little bit, just move this over here, and put another one here for or in ohms. And remember we said or is V over I, so that's equal to V, yeah. It's going to be 0.5 for all of them. Like that. Okay. Now tell me, if your graph changes a little bit, so there's V, there's I, and the graph goes like this. And then, for some reason, when you pass this number, the graph changes shape and goes like that. What has happened to the or? Has it gotten bigger or smaller?
Bigger.
Smaller. Because we said that the slope is 1 over or. So here the slope is bigger, so that means the or is smaller because it's the reciprocal. And if the graph goes like that, the or is bigger. Okay? Yes, are you listening, Go? It's okay? So in this blue one, is the or bigger or smaller?
The R?
Yeah, bigger or smaller here?
Smaller.
Good, okay, and here? Okay, good, you were listening. Just checking. Right. Ohm's law says that for some materials at a low voltage and a low current and a constant temperature, the IV characteristic graph will be linear. So what Ohm said is, if the V is small, so maybe like, for example, up to 1 volt, for example, okay, and the current is also small, maybe up to 1 amp, and you keep the temperature constant, you know, everything is a constant temperature. Ohm said that the graph should be, for some materials, a straight line. Now that's really a bad law. Like, really think about what he's saying. He's only saying for some materials. Which materials? Some materials. At a low voltage. How low? I don't know. Low. And a low current. How low? I don't know. Low. And keep the temperature constant. Then the graph will be linear. Okay? Do you get what I'm saying? It's not really a useful law. Right?
but every law should be actually. So everything, every law must be I think every law must be controlled.
Accuracy.
Accuracy, yeah.
Accuracy.
Yeah.
Yeah.
Yeah, that's what I'm saying. So it's Ohm's law.
But remember the formula.
Yeah, this very good. This is a very common mistake with teachers and students. Some people think this is Ohm's law, or sorry, that this is Ohm's law.
No.
No.
So
Or maybe people think this is Ohm's law.
no, the
No.
last one, another one.
I equals V over R. No. This is not Ohm's law.
Ohm's law just the sentence.
Yeah,
Okay.
just a sentence. Yeah.
I
This is a very common mistake, even with teachers. Even with teachers. Yeah?
I remember if we rise the temperature,
Yeah.
resistance
Resistance.
will rise.
Correct. Yeah.
But it doesn't.
Yeah, Ohm's law just said if the temperature is constant, then the graph will be straight. But you're right. If the temperature increases, the resistance increases. Not always. Usually. Not always.
Oh.
Yeah. Okay. So, sadly, Ohm's law is a sentence. This sentence. If you can write it down, please.
Okay.
We'll see this in the exam.
I hope no definition.
I would
from
no, it's a definitely.
physics.
I'd say 10% chance.
So I already
Write
gave
a
up for
full
chemistry.
sentence. Or
Yeah.
just
Full sentence.
and keep quiet. Just
A 10% chance you'll have to write this sentence.
Write whole sentence.
No, write half a sentence. Of course, write a whole sentence.
I nearly gave up for chemistry. You know, yesterday after finished the physics and we came out, we checked our email and we got mail from chemistry. The whole class, except I only know 3 of us, our chemistry grade. And we are not A star. And except 5% always A star. I was God.
Everyone got an A star except for 5
Predicted
people.
grade.
Yeah.
Predicted grade, but not you.
Not 3 of us.
Not 3. So the engineers.
I don't know.
Yeah. So you think 5 people didn't get a predicted grade of A, and you guys are 4 of them.
I don't
we
know
don't
Califas.
know Califas.
Yeah, you didn't get a predicted grade A, so you engineers don't like chemistry.
Give up. Because I thought my predicted grade is B or C.
Mhm.
I thought C is I'm satisfied because I'm nearly little bit got B, so I'm satisfied with this. And I thought it's really difficult because there's lots of definition. And when I see the pretty, you know, the table like A star, A star, A star, C, A star, A star, C, like this.
But the problem is, Gao, all those other students, they want to be doctors, you know, medicine, right?
But
Medicine, all of them.
but
Yeah.
chemistry.
Practically all of them. Practically all of them.
But chemistry for us is like EAP. I don't know what's the difference from the.
It's good for your English.
Difficult at EAP.
It's too difficult.
So maybe we use EAP, like maybe during the conversation or something, we can't say to the person about chemistry.
Of course you can. Why not? You wrote this down somewhere? Ben? Khalifa, you have the sentence?
Yes.
Yeah? How you
So
doing?
other like required grades for universities or like A for chemistry.
No, it depends on the course. If you're doing engineering, I think there's plenty of courses that would take B or C. Usually the engineering courses care most about your maths.
Yeah.
That's fun.
But chemistry. Too many definitions.
Don't worry, Summer. Lorraine is a very good teacher. Usually students do better in chemistry than physics. If you can believe that. It's true. Usually the chemistry grade is a little higher than the physics grade.
Maybe it's for another country's students. It's not for Chinese.
So
You'd be surprised.
I thought we only good at maths, and in maths class, all the maths students is A star, so it's nothing bad for us. It seems like.
We'll see what happens. We'll see. Okay, you have that?
So sad.
So sad.
Don't be sad. Okay, now, this is not always true, as I said. If it is true, then we describe the resistor as ohmic. So, if we do have this graph, okay, then we can say the resistor is ohmic. If this is true. Okay, ohmic. Otherwise, we say it's not ohmic. So, ohmic is the adjective. Do you understand? No, don't use the dictionary. Don't. Please. Trust me. It is better if you don't. Why do you need the dictionary for ohmic?
I do not understand what it's saying.
No. You guys are driving me crazy with your English. You're driving me nuts. Alright, listen.
Adjective.
Yes. Ohm is a person. That's a noun. It's the name of the resistance, the unit, right?
Yeah.
This is Ohm's law.
Yeah.
You see apostrophe S? Because Ohm is also a person. So this is his law,
Yeah.
right?
Yeah.
Ohmic, OHM, is the same here as OHM. The IC makes it an adjective. It describes something which obeys Ohm's law.
It's okay.
Yeah, so if it obeys Ohm's law, we say it is ohmic. Ohmic is the adjective. Okay, so you don't need the dictionary.
So we have the anic.
Which one?
Anic.
Anic?
Add the IC.
Add the IC to, let's see, so yeah, let's see. It depends on the person's name,
Yeah,
okay?
yeah.
So Ohm's law,
Yeah.
if you obey Ohm's law, then you're ohmic.
Yeah.
If you obey Newton's law,
Yeah.
then you're, no, sadly not, Newtonian.
No.
It's a different one depending on how it ends.
Oh.
So if it ends in an N, then it's IAN. If it ends with an M, then it's IC.
Yeah.
So for example, my name, if I had a Stephen law,
No Chinese.
Yeah. Stephenian.
Oh.
Okay, do you understand? Yeah. Who else did we have? Any other laws? Ooh, that's a hard one because it ends with an
Maslow's
E.
law.
Huh?
Maslow's law.
Maslow. Maslowian, I think? Yeah, IAN, I think. Okay, do you understand?
Yeah.
So now you see, you don't need a dictionary. Okay, so can you write this down?
English teacher.
I have a little bit. Okay. Got that? So, we saw that the slope represents the 1 over the resistance. So, if you didn't write this down yet, you should write it down now. The slope, the gradient of the graph is 1 over r. We were talking about that earlier. Yeah. Yeah? Continue? Yeah?
Yeah.
Right, now, I think this one here, we're good. this is an example of an exam type of question. So the first one they would say is, you would like to know the IV curve of a lamp. Draw the circuit. Okay, so the only thing that's different, the circuit, yeah. What is the only thing that's different here?
Lamp.
Oh, yeah, the lamp. So what changes? This is the circle now with the X. That's the only difference. Okay? So I don't need to do part A, do I? No. Part B, use the data, draw the curve. Okay, so the voltage I kept the same, but I've changed the current for the lamp. So let me redraw now. This is, what's this, 13.5,
13, 12, 11, 10, 8, 6, 4, 2.
10, 8, 6, 6, 4, 2. Yeah. Now, do you see how the shape's a little bit different? What's happening? It's bending, isn't it? So what's happening to the resistance as you increase the voltage? No, increases. 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 This is probably because, like you were saying earlier, Ben, the higher voltage makes the light hotter, which increases the resistance. Okay? That's part B.
So no.
Yeah.
Okay.
It's okay?
Okay.
C. Extend. What does that verb mean? Add. Add to the table the resistance. Now I've already done that. Do you see it? Here it is here. Yeah? And do you see what's happening to the resistance? It starts off small when the voltage is low, and then as you increase the voltage, the resistance increases. Yeah? Okay. What is the smallest and largest resistance? The smallest resistance is 0.5, and the largest?
0.7.
0.7. That's fine, isn't it? And lastly, is this material ohmic?
Yes. No.
It's not clear. I would say no. But the reason I'm saying no is because I think 10 volts is pretty small, and the graph is starting to bend. But this is the problem. What do I mean by small? You know?
Yeah.
Yeah.
Maybe
Yes, it's a problem.
Maybe our in the daily life we use the I don't know what's in your country.
No, I know, 220.
Yeah.
So 10 is kind of small
Yeah.
if you can use 220.
No.
It's fine. It's not clear. It's fine though.
Yeah.
It's fine to disagree. Okay, continue.
Okay.
I don't think you need to draw this, do you? Because you have an example from earlier. Yeah? Okay. Will it matter if we run the current backwards? For example, imagine back in my circuit at the start, I take this and I turn it around. So the current now goes down. It goes the other way. Does that matter?
No.
Not really, because all that happens is this becomes, yeah, but this becomes minus V and this becomes minus A. So on your graph, it doesn't really change anything. So if the material is ohmic, then it will be ohmic here as well. It's just negative, that's all. That's fine. Well, it doesn't matter for a simple resistor or filament lamp. The graph can be extended backwards, and I just drew that for you. It's just straight line still, okay? But if we look at something like an LED light, the direction does matter. So, do you remember the LED light was this symbol? What was it? This here? Yeah. It does matter. It does matter. Here, What happens in the LED light if the voltage is increasing? What happens to the resistance?
It's small.
Smaller.
Yeah.
This is the opposite to the filament lamp.
Yeah.
It's the opposite.
It's
Semiconductor. Yeah. So for example, something like that, the resistance increases when the voltage increases. But for something like on your phone, you know, the light is the opposite. The resistance decreases as the voltage increases. So that's why the graph goes up like this. Okay? And at the beginning, the voltage is really, really high, and now it's really, really small. So the LED is different because with these lights, if you turn the voltage down, what happens to the light? It's dimmer. If you turn the voltage up, it's brighter. This is not true with LEDs. With LEDs, they're just off or on. They don't have levels. Yeah. Do you understand? LED lights, they're off or they're on. That's it. They don't have steps. Okay? So it's high resistance, low resistance. Now, if you try to turn it around and make the current go backwards, look at what happens. Resistance here, very high. Very high, very high, very, very high. And then what happens? Yeah, very low. So this is when you break it. You break it. So here's my LED. I can put the current in. I get the light. I try to put the current in backwards. The resistance is very high. I increase the voltage. Still no good. High resistance. And then it breaks. And the current passes through. So
Break.
yeah, it breaks.
Oh.
It breaks. Because you push it too hard and now it breaks and the current passes through.
So what happened?
You broke it.
Okay.
You broke it, yeah. So here, this is called the breakdown voltage. This is where it breaks. This is the threshold voltage. In the exam, they ask you to draw this graph, and they also want to see what value this is. Is usually about 0.7 volts, this point here. That's normal, about 0.7 volts. Okay. So if you can draw that, please, with all the names. All the names. Then I think that's it. So once you draw this, you can go then. I'll just stop the video. There's no need to record while you're drawing.